Hello and welcome back to the Project Management PrepCast, where we take complex project management concepts and make them seem simple. I'm your instructor, Cornelius Fichtner. In this lesson, we look at the decision tree and expected monetary value tools and techniques in project risk management. First, we provide an overview of the decision tree. Next, we discuss the concept of mutual exclusivity. We move on to how to create and analyze a decision tree. We talk about how to calculate the impact value of a decision, and finally we explain the concept of expected monetary value and how to determine it. To make sure you get a good grasp of this lesson, we walk through a simple example of a decision tree and EMV calculation. We start with the main concept. This usually means that we highlight our most important points in green. In this lesson, as our something green, we give you an entire tree, a decision tree, that is. A decision tree analysis is a powerful tool that uses a branching method to illustrate every possible outcome of a decision. Sometimes you are faced with multiple options and you need help making a decision. With a decision tree, each branch shows an alternative path. Each of these paths represents different decisions or events with the possible associated cost. For example, on your project, you may need to choose between a contractor that is cheaper but is notorious for being late in delivering projects, or another contractor who is more expensive but who has a good track record for on-time completion of projects. You can draw a branch for each contractor on a decision tree. Decision trees can help you clarify the uncertainties of each option with respect to investment and time. When using a decision tree, you can evaluate the cost and benefits of several risk responses at once. The endpoints of the branches lead you to the outcome of each path and give you the ability to choose the best option. A decision tree uses expected monetary value, or EMV, to evaluate the impact of each decision or branch. We'll talk more about EMV when we run through our example. Before we can get into the decision tree diagram, we should discuss what is known as mutual exclusivity. Don't worry, it's a very simple concept to understand, I promise. Mutually exclusive events are things that can't happen at the same time. For example, a car is either on or off. It can't be both on and off at the same time. But you're not limited to two options. For example, in chess, either black or white wins or neither wins when you have a stalemate. If we now factor in the probability of occurrence of all events, the sum of the percentages always add up to 100%. For instance, the motor of your car is on 30% of the time and it is off 70% of the time. And this is what you need to understand about mutual exclusivity for the decision tree analysis. To understand how the decision tree works, we start by looking at the basics. A decision tree consists of boxes, lines that connect the boxes, and nodes. Decision trees have three kinds of nodes, which is a point where a choice must be made. First, we have a decision node. These are commonly represented by squares. In our drawing here, that is the green square over on the left-hand side. Here is where you make your first decision. Second, we have chance nodes. These are usually represented by circles. In our drawing, you see purple circles. A chance node identifies an event in a decision tree where a degree of uncertainty exists. A chance node should have at least two possible outcomes. Third, we have end nodes at the very right-hand side, represented by triangles. They are blue here in our example. In a decision tree, an endpoint is drawn as a small triangle with one apex connected to the branch. The endpoint is the location where a payoff value is identified. A decision tree is always drawn from left to right. The tree is structured to show how and why one choice may lead to the next, with the use of the branches indicating each option as mutually exclusive. So if one path is chosen, any others cannot. To illustrate how it's done, we go back to our decision on choosing a contractor. So, you are the prime contractor and you need to decide which subcontractor to use for a critical activity. You know that there is a $1,000 per day penalty in the contract with the client for every day that you deliver late. Our goal is therefore to minimize our expected cost. So, do we choose our lower bid contractor who would cost us $110,000 but is less reliable and there is more of a risk of incurring a penalty for delivering late? Or do we choose our higher priced contractor who would cost us $140,000 but is known to be more reliable and therefore having a lower chance that we are going to incur a penalty? How do we choose? Well, first we need to understand what the probability is of being late. To do any calculations on the impact of our contractor being late, we need to understand the probability of both these contractors completing their work late. For our lower bid contractor, we estimate that there is a 50% chance that they are going to be 90 days late. But remember mutual exclusivity, because this means there is also a 50% chance that they could complete their work on time. For our higher bid contractor, we assess that there is only a low 10% chance for completing the work late, and only at most 30 days late at that. This means that there is a 90% chance that they could complete the work on time. Now you might think, how do we get an actual calculation of impact? For this, we need to look at expected monetary value, or EMV. The best way to use a decision tree and help you make a decision is by analyzing the impact of your scenarios and by using the expected monetary value calculation. A decision tree uses EMV to calculate the impact of each decision or branch. You are calculating the value of each option. EMV is calculated by multiplying your probability by the impact. After your calculation, you select the better value. For example, with a deck of playing cards, if I ask you to draw a card, you have a 50% chance of drawing a red card and a 50% chance of drawing a black card. If you draw a red card, I'll give you $10. But if you draw a black card, you get nothing. So, what is your better option? Probably to draw the red card. It seems pretty straightforward, but you can back up your decision by calculating your EMV. We go back to our example because we want to first focus on just one branch where we analyze the impact of selecting the contractor who has the low bid, but a higher risk for not completing the project on time. So we need to calculate the cost of each branch in order to understand the impact of selecting the low bidder. First, we know that there is a $1,000 per day penalty. You can see there's a little minus in front of it because it's an expense. So if it were an income, it would be positive, but this is an expense. We would have to pay this, so it is a minus. To calculate the impact cost, we now consider that our low bid contractor has a 50% chance of being 3 months late, 90 days late, and so we multiply 90 by the penalty of minus 1,000 per day, and now we know that the impact for being late would cost us $90,000, again with the minus in front. But the good news is that there is also a 50% probability that our low bid contractor is on time. There is no penalty for being on time, so there is no impact. Our calculation is therefore zero. Next, we need to calculate the total impact value. We need to add our original low-cost bid and the impact for each scenario together. So, our low-cost bid cost us $110,000. Again, it's an expense, so there's a minus there. Then we add the impact of being late to that. That's another $90,000, which gives us a total expense of $200,000. So the impact value path for low bid for being late is $200,000 minus. Since there is no impact or expense for being on time, our low bid remains as quoted, which would cost us $110,000. Looking at this, don't you wish you could predict the future so you wouldn't have to do all these calculations? Now, I'm zooming into our decision tree just for the low bidder, and we plug in our results so that we have a clearer picture of our impact path value for the low bid contractor. We now know that we have minus $200,000 for being late and minus $110,000 for being on time. But we're not done yet. The numbers we have give us the impact, and we can now calculate our expected monetary value. We do this for both being late and being on time. We remember that EMV is calculated by multiplying probability by the impact. Since there is a 50% chance that the low bidder would finish late, we multiply 50% by the impact value of being late, which is minus 200,000, by 50%, which gives us a total of minus 100,000. Since there is also a chance of being 50% on time, we multiply the impact value of being on time with the same value as the bid, since there is no penalty. So 50% by minus 110,000, which gets us as minus 55,000. As the last step, we add both figures together to get the overall EMV for the low bidder. So we have minus 100 plus minus 55. Therefore, the expected monetary value for our low bid is minus 155,000. Let's plug these numbers into the branch as well. Here we are. I've already filled in the numbers. We can see each EMV based on the chance of being late or on time. Minus 100,000 there for the top and minus 55,000 at the bottom. And if you look at the numbers that are around it, you can already see, oh yeah, that goes from right to left. I have 200,000 at the top right times 50% gives me the 100,000, and I have a minus 110,000 at the bottom right times 50% gives me 55,000. So now you should already see how this calculates backward and forward. And then by adding the two figures up, we get to the overall EMV for our low bid contractor, which is minus 155,000. That was the calculation for our low bid contractor. We now need to do exactly the same calculations with our high bid contractor to determine the impact path value. We're basically going to be repeating the calculations just with different numbers. First, we consider that there is a $1,000 per day penalty and we figure out the impact. Our high bidder is much more reliable and that there is only a 10% chance of being 30 days late. We multiply 30 days by the penalty of minus 1,000 per day, and we therefore figure out that the impact of being late would cost us $30,000. The higher bid contractor has a 90% chance of finishing on time, so there is no penalty for being on time. Therefore, there is also no impact. We next calculate the impact path value by adding the total penalty to the original bid. Our original bid cost us minus 140,000, so we add the impact of being late, which is minus 30,000, to get a total of minus 170,000. Since there is no impact or expense for being on time, our high bid remains as quoted, which would cost us $140,000. Let me quickly plug these results into our decision tree and take a look. And here we go. We now see the impact value on the right-hand side for both branches of our high bidder, minus 170 at the top, minus 140 at the bottom. And if you look at the numbers from left to right, you can pretty much just add them up. We have minus 140 plus minus 30 at the top. That gives us the minus 170. And for the bottom, we have minus 140 plus 0. That's still minus 140. Now that we have the impact path values for the high bidder, we can now also calculate our EMV for being late and being on time. Don't forget, the equation is very simple. We simply multiply probability by the impact. So, since there is only a 10% chance that the high bidder is going to finish late, we multiply 10% by the impact value of being late, which is minus 170,000. That gives us a total of minus 17,000. Since there is a 90% chance that the high bidder would finish on time, we multiply the impact value of being on time, which is the same value as the bid. There is no penalty, so 90% by minus 140 gets us at minus 126,000. We need to consider the late and on-time branches to establish the overall EMV, so we have to add minus 17 plus minus 126. The expected monetary value for the high bid is therefore minus 143,000. As we did before, we go back to our decision tree and we plug in our results. We see each EMV based on the chance of being late or on time. And again, you can calculate this now from right to left. So at the top, we have minus 170,000. 10% of that is minus 17,000. And at the bottom, we have minus 140,000. 90% of that is minus 126,000. And if we add these two up, we see the overall EMV for our high bid contractor. Okay, what do we do now? Well, we need to make a decision. Remember, we wanted to choose the one bidder which would cost us less? Now we compare the EMV of our low bid contractor at minus 155,000, that's an expense of $155,000, with our high bid cost at minus 143,000, that's an expense of 143,000. Based on this, even though our high bidder would cost us more outright, we discovered through this analysis and calculation that his reliability would likely pay off and be less risky and costly for us overall. With the EMV, you usually choose the higher value. So don't get confused here because we have a minus sign in front. In this particular instance, minus 143,000 is the higher value than minus $155,000. So that's why we go with minus 143. In contrast, many times we look at the investment or payoff of a decision. And when this is the case, then your EMV would have a positive value. Here is the completed decision tree with all the numbers added. It supports the decision that we have made. After going through each path and comparing the expected monetary value of each path, we should choose the path with the largest EMV and opt for the contractor who bid $140,000. With decision trees, you may have quite a few calculations to make. Another way is to keep track of these calculations for different scenarios by creating a table like a spreadsheet in Excel or a similar application. You get exactly the same answer there at the bottom left. But keeping things organized becomes especially important when your decision tree gets complicated with many more branches than what we had here in our example. We have come to the end of our lesson, so it's time to look at our key takeaways. Decision tree analysis is a powerful tool that can help you make decisions in many different project management situations. Once a decision tree is drawn, they are simple to understand and interpret. People can understand decision tree models after just a very brief explanation. Calculating the EMV of each possible decision path is a way to quantify each decision in monetary terms. And this concludes our look at the decision tree and the expected monetary value. Until next time.